Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 17th. Tonight we'll be discussing Jetstream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we have a gale in play. Just southeast of New Zealand with seas in the, about 44-foot range? Yep, and aimed well off to the east, not so well to the northeast, but hey, any sort of gale is good, and it's north of the ice line, so there is hope looking forward. As usual, we'll start our tour looking at Jetstream level winds. These winds have about 30,000 feet to help support the formation of gales. When they form, help direct their track. We're looking for a trough that is a push in the north to the jet stream, and we really don't have that. But here's the northern branch, but it's the southern branch that's most influential. And yes, I guess you could say there's a little bit of a push to the north there. There's winds at 150 knots, mainly pushing off to the east. That would help create a clockwise flow aloft right here in this area. And also down at the surface, that's the hallmark of low pressure in the southern hemisphere. And of course, if low pressure is deep enough, it produces winds, and winds, if they're strong enough, produce seas, and seas, if they're large enough, as they radiate away from the fetch area, turn into swell, and swell, if it's big enough when it hits your beach, turns into surf. So there is a little bit of potential just looking at the jet stream hill. Now, we've already cheated. We've looked at the wave models. We know something's going on here, but just eyeballing it at the jet stream level, you go, maybe not so much, but we'll see. Let's see. So let's roll this out. And so that trough right in there continues into Monday, and then it starts fading on Tuesday. And notice now you see what we call a ridge, the jet stream pushing to the south under New Zealand. For the most part, that pretty much shuts down potential for gale development. Now notice it's going south here, but it's rising in this area. So maybe there's a new trough going to start forming here on Wednesday night. Yes, and you see it, but not a whole. That's a more classic looking trough, but winds are exceedingly weak at 90 knots, so probably nothing's going to form from that. Then another trough is forecast come Thursday, starting to develop under New Zealand. Nothing super great, but some sense of wind energy moving there. Continuing into Friday, we'll say, maybe Saturday, and then it looks like another ridge setting up. The ice line we know is somewhere around 66, 65. We'll take a look here in a minute when we get to the wave models. But there, another ridge building, that'll shut down potential for gale development. But it also looks like a trough 180 hours out could be starting to build here in the central South Pacific. So, all in all, there's one trough now, another trough about midweek, and yet maybe another one a week out from now. Not too bad, especially considering all the other kind of not so good things that are happening in the atmosphere. Take whatever you can get. So next up, let's take a look down at the surface. Surface level wind, surface level pressure. To generate seas, you have to have winds not up, at 30,000 feet. It actually has to be wind blowing on the ocean surface without any ice there, right? And that the wind imparts energy to the ocean, and that's what generates swell. So right now, we have a gale with 40-knot winds building south of New Zealand and aimed a little bit off to the northeast, but not really much. That gale continues into Monday, but notice it's getting weaker, 35-knot winds, maybe a little tiny area of 40-knot winds, and then just gone by Monday night. Nothing really happening. Another tiny little gale tries to organize on Tuesday, but not a whole lot going on there. But you see something broader starting to percolate under New Zealand as we get into, we'll say, Wednesday night. Broad area of 40-knot winds. Now notice these leading edge winds here at 45 knots are pushed due south, so they don't count. And the Great Circle Pass into the U.S. West Coast go down about like this, so that fetch is probably in the Great Circle paths to California, not so much for Hawaii until it gets clear of New Zealand here, and you see the winds are pretty much aimed west to east. So, but still, broad area of winds 30 knots or greater. Some swell will result from that. That continues into Friday. And notice a secondary fetch building behind that, both tracking off on Saturday. Now, we know the jet is supposed to start reorganizing in this area when we get further out in the models. So look at this, a tiny little storm, 50-knot winds building into Saturday. And then a far broader area behind that of 40-knot winds. And where are we? We're almost, oh, wow, look at that. So this is a great setup. Look at this. 45 to 50 knot winds, a broad area of 40 to 45 knot winds behind that, covering a huge area of the ocean. Now, it's not aimed super well off to the northeast, but, you know, you take what you can get. But then as we get into, theoretically, a week from now, that fetch pretty much aimed due northeast, and the same deal here. So there's decent potential in the southern hemisphere. All right, we'll take it. So let's go take a look at the wave models. Now we're going back a week. This is Sunday last week, the 10th of May. There was a gale in the central South Pacific, pretty broad area. This is the last part of it. It was still generating 32, 30, almost 34-foot seas, and then it faded on, let's say, Monday morning. Now the interesting part here is that that swell is starting to hit California right now, in conjunction with swell from another system in the North Pacific, also hitting California at the same time. Also, as a cold front hits, generating a bunch, at least up in central and North California, a bunch of southwest winds and just a convoluted mess of southern hemiswell, north swell, and a bunch of local wind swell, and just not really good conditions for surfing, except at very select, well-protected breaks. All right, so anyway, last week, that system faded out, and really nothing came behind it. And now here we go. We're Saturday, yesterday, a small gale started developing south of Tasmania with 43-foot seas, building to 50-foot. Last night, it was up to 53-foot seas. And then pushing this morning, it was 48, almost 49-foot seas, pushing east under New Zealand. Now, not aimed very well to the north, so this really limits the amount of energy pushing in towards Hawaii. A little bit better for California, but best for, we'll say, Central America down into Peru. Regardless, swell is being generated. All right, so let's go off and take a look at the forecast now. All right, so we go into this evening. This gale starts fading, but not before it has generated a pretty good area of seas and likely swell radiating again. So that'd be about 8 days from now. We'll say not next weekend, but just after that probably. And basically, there's surf queued up all this week from the previous gale, so not bad. And then what's this? Another gale starts developing Wednesday night. We saw that in the Jetstream. As we get into Thursday, theoretically, another area, 41-foot seas pushing under New Zealand, continuing east, sort of doing the same thing, not really pushing off to the northeast, just straight zonal west to east type direction, and then actually holding together till Saturday. That's a pretty good long run there. And then this is that new little fetch we saw that had 50-knot winds in it. Seas building to 38 feet. The secondary, up to 40 feet on Sunday. So this is almost a week out with a broad area of seas behind that. Continuing, here we go, 180 hours out. That's a large area of seas, all aimed off to the east and northeast, so swell from Chile the whole way up into California. Seems possible if the models verify. This is still a week out, so don't believe the models that far out, but things are looking promising. So we've not looked at this one before, but this is something we built a while back. It's basically an accumulation of all the seas greater than 20 feet over the next 180 hours. And what you see is a giant portion at some point over the next week is supposed to have 30 foot is the purple, 30 foot or greater seas. The grays are 40, and some areas to 42 or 44 feet embedded in that. Basically, a huge area at some point over the next week is supposed to have seas capable of generating, we'll say 16 or 17 second period swell or better aimed to the north. This is pretty impressive. So let's go take a look at the current situation. We're looking for wind swell potential now. Now, there's this little low, what is it, 1,000 millibar low? That is nothing much at all. Off the coast of, we'll say, Central California, producing southwest winds. Yeah, it's generating wind swell, was that 15, 20 knot wind, so 8, 10 second period wind swell, maybe something like that. Nothing impressive. And relative to Hawaii, not a whole lot going on. Light trades. That fetch is supposed to continue into Monday, pretty much just junking everything up. Trades trying to build north of Hawaii as we get into Tuesday at 15 knots, but probably not large enough to, a fetch area to really have any traction till we get into, we'll say, Wednesday. And notice high pressure just starting to fill the entire Gulf of Alaska, setting up likely north winds down the California coast, local northwest wind swell. Trades not really consistent enough, continuous enough at 15 knots to generate much for east shores of the Hawaiian Islands. But certainly the typical summertime pressure gradient setting up Thursday for California, continuing stronger with up to 30 knot north winds off of northern California as we get into Friday. And let's see where, and look at, that's solid, 30 knots. Even as we get into Saturday, the gradient starts fading. Still, no solid fetch here for the east shores of the Hawaiian Islands. We're into Sunday, wind swell, still the name of the game. We'll go out, and here comes another little low pressure in the North Pacific. Maybe we should go take a quick look here at the wave models just to see what they're saying for the North Pacific. So here we are today. Quick look, significant wave heights for the North Pacific Ocean. We're looking for anything that's, we'll say, 20 feet or so. And yeah, okay, a little system forecast on Wednesday over the North Dateline region, 20-foot seas, not really doing much and just sort of fading out. But it was that one that was on here. It is right here. We're 180 hours out and seas 16 feet. Okay. So basically nothing. We'll keep our eyes on that, but for right now, it appears the North Pacific is asleep. The whole focus is the southern hemi. It's in a pretty good groove. You saw the wave models. You saw the weather models. The Jetstream doesn't really suggest as strongly as good of a pattern as what's actually forecast to happen down at the surface. So that gives us a little bit of pause that says maybe the models are overhyping it a little bit, but we'll see. And then finally, precipitation potential. Well, we know in California, at least in North and Central California, it rained today. Not piles, maybe a 1/4 inch in the Bay Area, maybe a little bit more, but, 1/3 of an inch. Road's pretty wet, not enough to really soak the ground or anything. And you can see the front making it down to, we'll say, Point Conception later this evening. No snow. Temperatures just looked in the Squaw Valley area, even up at 8,000 feet, we're still 40 degrees or something like that. So there, supposedly, by tomorrow morning, cold air gets entrenched, snow building for the Sierra, a little bit of rain for north and even down into Southern California tomorrow morning, if you believe that. Snow, not enough to really make a difference from a ski perspective, but if you're doing some if you're in the high country, take note, there could be 10 inches, maybe, at the highest peaks with a bit of luck. All right, so we get into Tuesday. High pressure starts building in. We know the gradient's setting up. Now, you notice the dividing line is just north of California. It's still precipitation up into Oregon and the Pacific Northwest, but nothing for California over the next week other than today and tomorrow. So that's pretty much likely the close of the rainy season for California. All right, let's go take a look long-term. What's going on with the Madden-Julian oscillation? Typically that pattern, periodic weather oscillation, that feeds the jet stream, that then in turn feeds the storm track if it's in the active phase. And of course, what's going on with El Nino or La Nina? We'll find out in a few minutes. So first off, the MJO examination. We're looking for the active phase of the MJO, and as you all know, the MJO is this periodic weather oscillation. It traverses the whole way around the planet on the equator from west to east, first in the active phase and then in the inactive phase. It takes about 3 or 4 weeks for either phase to make its traverse from west to east on the equator across the Pacific. First the active phase, then the inactive phase. All right, so the active phase, typically what it does is suppresses trades, and that in turn allows energy to travel higher up into the atmosphere, which in turn feeds the jet stream, which then feeds the storm track, which then produces storms and produces surf, ultimately. Looking at the wave models, you go, hey, we're in the active phase because there is a healthy good storm track forecast for the southern hemisphere. Now, the caveat is the MJO, especially in the southern hemisphere, especially in our summer months, the correlation is not that great. I mean, there's always the potential that even in the inactive phase, you can get storm development. So it's not a switch that's on or off. But when you get a good, healthy, active phase and everything lines up, you can really get some amazing storm development. All right, so anyway, what we're looking for is weakening of trades. This is data from the TAO buoy array, a series of buoys strung across the equator. This is the East Pacific here, West Pacific here. The arrows are the sensors on the buoys, the wind sensors. So, and this is 5-day average winds, and you can see pretty strong out of the east, from the East Pacific over the Central Pacific and into this thing we call the Kelvin wave generation area. Fancy words for the West Pacific, but when the active phase of the MJO is here is in the West Pacific, that's where if you get reversal of trades, that's one, where the energy gets pumped into the jet stream, and two, where you can get creation of Kelvin waves. And Kelvin waves, if you get successive of them, one right after the other, that can help form El Nino. All right, so right now, trades pretty strong the whole way across the Pacific. Anomalies, the difference from normal for this time of year. Now, the trades, you know, they blow stronger sometimes a year, weaker other times, so you have to consider what time of year we're in. So you look at the arrows here, you see little bit of, maybe the trades are a little bit stronger east here in the far East Pacific, but pretty neutral. And we're only looking 5 degrees north and south of the equator, pretty much normal over the Central Pacific. And in the Kelvin wave generation area from 170 west, 5 degrees north and south of the equator, to 135 east, right, a box right in there. See, trades, yeah, a little bit stronger out of the east, but not too bad. This time of year, I mean, the trades typically blow strong in spring. What have the trades been doing for the past 5 days? Okay, this is kind of a tough chart to read, but there's South America, Central America, Mexico, the equator, 0 degrees right there. Okay, so this is the West Pacific. There's Australia, New Guinea, Kelvin wave generation area right in there. So that's where we're looking at. The blues would be easterly anomalies. You can see, and this is wind anomalies. So this is difference from normal. We see winds pretty strong out of the east over the we'll call it the central equatorial Pacific, but kind of neutral in the Kelvin wave generation area. That was on May 11th, and just sort of going down, you see pretty much a continuation of that pattern, these easterly anomalies just holding solid. And oh, notice this, easterly anomalies as of the 15th of May, building in the far West Pacific. That sort of smells of the inactive phase of the MJO. All right, and so now we'll look, so this is past performance, 850 millibar zonal wind anomalies. That's just the east-west component of the wind. Are the trades on the equator, 5 degrees south to 5 degrees north, blowing stronger or weaker than normal? Here we go. So the Pacific starts at about 135 east, so you go right up there in your mind's eye. And then the far East Pacific is about 80 west, about right there. You can almost see a seam right there in the model where that is. Okay, but Kelvin wave generation area, that's where what we're interested in, from here to about here. So we go right up here. You can see back in April, early May, the blues are easterly anomalies, stronger than normal. Probably this was the inactive phase of the MJO. If this was an active phase, it is very weak and non-existent. You can see the forecast here. This is where things are really interesting. So here's the Kelvin wave generation area and just raging east anomalies. One would think that would just completely crush any storm development in the southern hemisphere. But we looked at the models. We know that isn't true. So this is a glaring example of how, on occasion, the MJO, even though in the inactive state, even with raging east anomalies, that does not completely shut down the storm track. So that's good news for us. We'll take whatever we can get. So let's dig a little deeper into the MJO. This is outgoing long-wave radiation forecast, sunlight reflectivity off the ocean surface. Active phase of the MJO acts like low pressure going across the equator. That would mean more clouds. The blues are consistent with more clouds. The yellows, oranges are more sunlight reflectivity. Think of it as high pressure and clear skies. So inactive phase of the MJO today, 5 days from now. Now, according to the statistic model, about a week from now, that inactive phase is to be fading, and the active phase is supposed to start building and filling the Kelvin wave generation area 2 weeks from now. That's pretty nice. Now we go look at the dynamic model, the Cfs model. It's not quite as robust as the statistic model here, suggesting, yes, the inactive phase fading. We're good with that. But the active phase, just not nearly as strong, just a nub of it, where the statistic model says a much more robust pattern. The reality is probably somewhere in between the two, so a middling to weak active phase 2 weeks from now. Continuing with the MJO discussion, digging a little deeper, where is exactly the active phase of the MJO? Okay, so this chart, they call it a phase diagram, all right? So the MJO moves from west to east, right? From the Indian Ocean, over the maritime continent, that's like Bali in that area, into the West Pacific, across the West Pacific, over the East Pacific, on the equator now. So it would be underneath the United States, over the Atlantic, across North Africa, back to the Indian Ocean. The heavy dot is where the active phase is, and the further away the dot is from the circle, the stronger it is. So we'll say a pretty weak active phase over the Indian Ocean today. 3 different projections, one saying it just basically dying there. This is from the statistic model. The more robust or optimistic version says, hey, a moderate active phase making it into the West Pacific 2 weeks from now. The Cfs model, a dynamic model, says, yeah, kind of very weak active phase 2 weeks from now, working its way into the West Pacific to the East Pacific, and very weak at that time. It's inside of the circle, the dots are here. So that suggests probably a very weak to modest active phase likely. Continuing with the MJO discussion, all right, precipitation potential, another way to look at the MJO. If the MJO is equivalent to low pressure traversing the Pacific on the equator, then it has the potential to produce precipitation. So right now, the yellows and oranges, this is South America here. There's Central America, Mexico up there, New Guinea there. There is the equator, right? Okay, date line's roughly about there. So you see, the yellows, oranges are areas not favorable for precipitation. Basically, the inactive phase of the MJO. It's over the Central Pacific today, supposed to push into Central America on, say, June 6th or so. But the active phase is supposed to start building, kind of a modest one, May 27th in the far West Pacific, making its way across and into Central America, we'll say mid to late June, and then followed by a weak active or inactive phase behind that. So the MJO, at least according to this and many of the models, all is looking very weak, but we know that there's some signals. I mean, you saw the easterly anomalies that are forecast in the Kelvin wave generation area a week from now. That's so maybe not coupled with the MJO, but it still has the same effect. All right, the Cfs model, another MJO model, going out a month this time. All right, and we don't really believe a model that goes out a month, but it gives you kind of a clue as to what's going on. All right, so again, Kelvin wave generation starts at 135 east, so right about there. Kelvin wave generation area ends about 170 west, so right about there. Here's where we are today. The blues are easterly anomalies, and you see quite clearly strong. Here's that strong pool of easterly anomalies forecast for, we'll say, the next week. The good news is the real strength of it is supposed to be gone a week from now, but still you see just consistent easterly anomalies filling the Kelvin wave generation area for the entire month. This is supposed to be the active phase, this solid contour here, and you can kind of connect the lines all together here and say, yeah, here's your active phase that's in late May, early June, but it just is going to have a very hard time getting any traction in terms of westerly anomalies, and the westerly anomalies are what feed the Jetstream, blah, blah, blah. So just again, this continuation of the prevalence of easterly anomalies, and we'll be quite clear, when that happens, that typically is a sign of a developing La Nina. And then, if you don't believe a model that goes out a month, then why would you believe a model that goes out 3 months? But we like to do that because it does, maybe the details aren't right, but it does. This model so far is doing pretty well at giving a general sense of where we're going. And to just tell you how good it is, months ago, it was saying that water temperatures were going to start dropping over the equator, and pretty precipitously, and that is exactly what's happening. Now, the details of exactly what day it's going to happen and all that, it doesn't get right, but it gives you the general overview of what's going to happen, and you can build some plans around that. All right, so anyway, so this is the same deal. Whole planet on one chart. Kelvin wave generation area starts here and goes to about here. Now, this is past performances at the bottom. You can see in the yellows and oranges are westerly anomalies, actually westerly wind bursts that created a Kelvin wave. This is back in February and January. Since then, you see the westerly anomaly pattern has just gotten weaker and weaker. Easterly anomalies building, and you just, without even looking at it, you just go right up the chart and you see, wow, easterly anomalies are just forecast to take over the Kelvin wave generation area as we get basically starting sometime in June and from then on. And that, again, is a sign of La Nina. Now, we'll overlay the MJO, and we'll see what it's supposed to do. Inactive phase today, all but gone. Supposedly the active phase building, but we know we got strong easterly anomalies coming the next week. So whatever active phase this is, it isn't much of one. Maybe a little sliver of westerly anomalies traversing the Pacific on the equator in early June. Then another inactive phase, another burst of easterly anomalies, pretty much filling the entire Pacific Ocean. Another active phase that just is weak in terms of westerly wind potential, doesn't do anything. And after that, easterly anomalies just take over the Pacific Ocean. Now, why is that? Well, let's overlay the low pass filter. Here we go. And it's pretty obvious what's going on. So we've been through this 2-year pattern of where westerly anomalies just ruled supreme in the Pacific, and theoretically that was good for storm development, but we noticed somewhere this winter that really started falling apart. And you can see, so this solid contour is what you would call a low pressure bias, low pass filter. The solid contour, low pressure bias. That would be like a La Nina, a tendency towards El Nino. A tendency towards El Nino. You see this dotted contour here? That is a high pressure bias. That's been in the Pacific Ocean and in the Indian Ocean, and kind of locking things down there, making for a dry, just miserable mess of a pattern there. And so this sort of looked like El Nino. But if you look up here, starting in June, you see the high pressure that was in the Indian Ocean is supposed to start building over the Pacific with up to 2 contours, and the low pressure that was in the Pacific retrogrades and sets up in the Indian Ocean, and this is what's going to drive these easterly anomalies. Basically, this is the classic setup for some flavor of La Nina. This model's been saying it. Everyone's been trying to weasel out of why the Cfs model isn't right. No, it doesn't know what it's doing, and it's sensing some things that aren't right. But as we get deeper into this presentation, you're going to see, at least at this point, this model seems to have had a heads up on everything else, and it was the outlier, the minority report, if you will. But in the end, it had better insight, at least so far, than any other model we've seen. All right, enough MJO discussion. What about El Nino or La Nina? What is the atmosphere? What is the ocean? What are they doing in response, or what do they think is happening? All right, so this is data from the TAO buoy array. Again, there's buoys strung across the equator. This is the West Pacific here, East Pacific here. These are the anchor lines on the buoys. The X's are the sensors on those anchor lines. There's wires that run up the anchor line, take the data, beam it up to a satellite. The satellite collects all the data from every one of these. Each one of these is a sensor, and they're thousands of miles in the middle of the ocean. It's all solar powered, battery operated. I mean, it's an amazing bit of technology, kind of basic, but it works really well. And then you use a model to string the data to fill in the gaps, and you get a profile of the subsurface ocean temperatures. And that's really important because a Kelvin wave is effectively warm water that travels from west to east under the equator, not on the surface, but under the equator, driven by a westerly wind burst from the active phase of the MJO. If you have a strong enough active phase, take this warm water right there. See that? 30 degrees centigrade, multiply that times, was it 1.8 and add 32 degrees to convert to Fahrenheit. But anyway, warm water here, basically about where it's been. It's actually building a little bit. So typically during La Nina, you get easterly anomalies, takes all the warm water that's in the west and that's in the east and pushes it off here to the west. So you can see it right there, 30 degree, 29 degree isotherm. It was actually back about 176 east. It's moved a hair bit to the east, but not much. 28 degree isotherm, 163. It was at 164 west last week, so pretty much unchanged. The difference here is the 24 degree isotherm. It was pretty thick here last week. You notice it's almost right at the surface. That's 15 meters down. So it's reality, it's probably about 10 meters, 30 meters deep. Colder water at depth here. The isotherm is getting thinner. Warm water is getting thinner. That means our warm regime, at least for the minute, appears to be weakening. Let's look at anomalies. Differences from normal for this time of year. All right, and you can see clearly there was warm water. We've been watching Kelvin wave after Kelvin wave make its way across the Pacific, filling up and creating a warm pool here from about 25 meters up in the far east Pacific. Now we see -3 degrees centigrade temperatures, a big pool working its way to the surface near here. What is that? That's probably about at 120 west or so, 120 there, 130. So that's due south of California on the equator. This is, again, another La Nina signal. When you have cold water building under the equator and upwelling to the surface, then that is definitely not a sign of El Nino. Here's another model. It shows it even better. So they say it updates every 5 days, but if you actually look at the chart, and you sort of just keep your eyeballs on it, you'll see. So 3 days ago, there were still pockets of warm water up here. They're all gone now. This is the last couple little pockets of warm water in the far east Pacific. Cold water, you literally can see it getting sucked up to the surface. And just the expectation is this whole pool's just going to go boom and erupt right here at the surface. And then we'll see a building, cool pool building on the equator, in where normally you would want to see warm water building if you were in a El Nino pattern. This would be the classic kind of setup for development of La Nina. Sea level anomalies. So this is not temperatures. This is the height of the ocean. Strip out the waves, strip out the wind waves, strip out the tides. This is South America here, Central America, Mexico. There's the equator. Dateline right there, New Guinea. And we see -10, a solid pocket of -10 centimeter anomalies. Here's the Galapagos here. Here is Ecuador, and 10 centimeter here. So basically you see this whole tongue of cold water. You can actually see it. It's tracking to the west. You can actually see warm water in the West Pacific trying to wrap around it, as this is just like a knife going right into the heart of what would be the Kelvin wave generation area, the El Nino generation area, the area for transporting energy up into the jet stream. Cold water in control. So this is cold water contracts, right? So that would make a divot on the ocean's surface, and that's what this satellite is measuring here, the divot on the surface, -10 centimeters. So suggestive of a broad pool of cool water setting up on the equator. Upper ocean heat anomalies. So this is sort of a historical view of what's been going on in the past. This is the West Pacific here, East Pacific here. We're going back a year, June last year. This is warm water. Yellows, reds. warm water from a Kelvin wave from the active phase of the MJO pushing across the Pacific last summer. It didn't make it, though. It didn't make it the whole way across the Pacific. It stalled. We got a developing cool pool here. But then magically in September, we got a active phase of the MJO, created a Kelvin wave. You see it right here, pushed the whole way into Ecuador. That was great, and that sort of set us up at least a little bit this winter, gave us some hope. And there was another Kelvin wave or active phase in November, December, January time frame. We saw that actually westerly wind bursts, created another Kelvin wave. But then here's where we are now, and you can just see no warm water in play anymore. It's just building in the West Pacific, but we know, one, we've looked at the MJO models. There's no real solid active phase forecast anymore. There's no westerly anomalies forecast, nothing to create a Kelvin wave. Instead, we have trades building stronger than normal, creating upwelling, cool pool deep in the surface, erupting at the upwelling to the surface, creating cool anomalies. Again, the hallmark of La Nina. And then we look at sea surface temperature anomalies. It's real obvious. So there's not actually two of these. The images takes all four of them, but they kind of overlap, cover the same area. But you can clearly see a broad, cool area of ocean temperatures developing on the equator from, we'll say, 110 west, south of Mexico, the whole way out almost to the date line. Hallmark of La Nina. Now, the other thing, though, is warm water along Peru and Chile, and warm water from the previous El Nino-like pattern off of Central America and just north of the equator, just like 2 degrees north of the equator, going the whole way across the Pacific. So we're in transition, right? The remnants of what was a sort of barely El Nino fading out with the development of a La Nina-type regime. Here's a 7-day trend. Real simple. Blues are colder. Temperatures trending cooler right on the equator from just off Ecuador over the Galapagos out to maybe 150 west, but you don't see any warming at all. So even out to the date line, and no real warming 5 degrees north or south of the equator, just these couple of little random pockets. But the obvious signal here is dropping cooler. And then the real signal here. This is just sea surface temperature anomalies, the broad view looking at it, obvious cool pool developing. The official El Nino region from a sea surface temperature perspective is from 120 west to 170 west, 5 degrees north and south of the equator, right in there. Now this is, yes, it is a cool regime, but this is not by any stretch some raging La Nina sort of thing. This is a very early stage, just sort of a teaser thing. Yeah, the peak of La Nina probably would happen in the late November, early December time frame. So if this, but the thought being is this starts, then it starts working its way, start having effect on the atmosphere. Then the atmosphere changes. It reinforces the east wind trade pattern. Then you get more upwelling, and it just, it just starts feeding on itself and building and building. And what the net effect is, it'll take all this warm water here and eventually push it over into here, and it'll start building and building. It might take a couple of years. And then that's how El Nino happens. At some point, you have so much warm water here, the trades, they just have to be nuking to hold all the warm water there. But basically, it's all building up in the Kelvin wave generation area. And at some point, all it takes is just a little push of the active phase of the MJO, and boom, the whole house of cards collapses. And then the exact opposite happens. Then all of a sudden, you start getting westerly anomalies, warm water Kelvin waves, and then perhaps El Nino. But for now, the momentum at the moment looks like we're pushing towards La Nina. Sea surface temperature trend in the Nino 1.2 region. This is the area on the equator right there by the Galapagos, Ecuador, maybe down into Peru a little bit. Temperatures were, back in February, March, about 0.6 to 0.8 degrees above normal, not even a degree. And then steadily falling. Today, basically dead neutral, 0.049 degrees above normal. That's that little dot there. We'll call it neutral. But it's the official El Nino monitoring region, the Nino 3.4 region. That's what really counts. And that, too, all winter was warm, not super warm. It has to be half a degree above normal for 5 consecutive 3-month periods. Okay, we got in that threshold above half a degree in second week of March, and it lasted till about the third week of April. And now this is exactly what the CFS model said months ago, that somewhere I think it was saying in late April, maybe even early April, the temperatures would precipitously drop. That's exactly what's happening. We went from 0.6 degrees above normal to 0.285, almost 0.3 degrees below normal in the period of 4 weeks. That's, in terms of meteorology, that's a pretty precipitous drop. So let's go look at what does the atmosphere think is going on. I mean, clearly the ocean's going both subsurface and at the surface. They're primed to move towards La Nina. But what is happening in the atmosphere? Does it sense it? And the atmosphere tends to sort of it lags behind. If the ocean really gets on board with all this, then it will change and go along with whatever the strongest trend is. So this is the Southern Oscillation Index. Difference in pressure between Tahiti and Darwin. All right. When pressure is lower in Tahiti, the index goes negative, and if it stays negative for a couple of days or a week or so, then that would be a sign of the active phase of the MJO. If it's positive, then the inactive phase. If it stays negative for many days in a row, like 30 days in a row, then that's clearly a sign of the active phase of the MJO. 90 days in a row, then you're moving towards El Nino or La Nina. All right, today's contribution, positive, 11.51. So tending towards the inactive phase. And looking down just for the past couple of days, the numbers have been positive. Actually, they've been positive since May or even earlier than that. All right, 30-day average, what's it doing? It's rising. We were at minus 9.3 May 1st. We're at plus 2.72. So moving towards a inactive phase. And then the 90-day average, well, we were at we'll say minus 3. We're at minus 1.28. So it's rising. But where were we? We've never been below, let's say 0.309. Oh, 0.32. There we go. In April 28th. So we're rising, but not super strong. So the atmosphere is not sensing some strong La Nina thing at the moment, but it's just saying, well, maybe we're moving towards a neutral pattern. Here's a 30-day SOI graphed out so you can see when it's negative, that's the El Nino, positive La Nina. These changes, the drop down are the active phase of the MJO, the push up is the inactive phase of the MJO. So you can see the trend is definitely moving towards neutral. That's not so bad. Neutral's not bad. But the sense is that we're moving towards a positive regime. Now, we were in a positive regime back in 2018. It wasn't the end of the earth. It wasn't a strong La Nina. Don't know that we're moving there this time either, but certainly the trend is positive. Here is the official sea surface temperature forecast, sea surface temperature anomalies for the Nino 3.4 region, the official El Nino monitoring region, from the CFS model, of course. And here is that spike we were talking about. So here is the solid line is actuals, and then this model said, it was actually in early April, it said it was going to make the big drop south. Well, it actually started May 1st. You can see it there. Now, the good news is this model originally had temperatures going down to 1.5 degrees below normal. Now it's moderated and saying down to about half that, 0.75. That's still definitely La Nina territory, but not just a crushing La Nina. So anyway, as we get into fall, moving into a La Nina regime and holding there until maybe about February per this model. So the CFS model also does sea surface temperature forecasts like in a chart style. This is kind of hard to look, so I'll just blow one of these up. So this is for June 2020. You can see there's the cool pool actually building, kind of classic, kind of La Nina type pattern, and actually cooler temperatures building along Ecuador too. We don't have that. Remember, we have warmer temperatures right here, right now. So that deepening. And then in September, you see the pattern continuing, bigger area of cool anomalies. I mean, this is the classic kind of La Nina, not super strong one, but a classic La Nina sort of pattern. East trades, creating upwelling here, pushing cool water into the heart of the Kelvin wave generation area, and pretty much shutting down Kelvin wave production. And then in November, the same thing, pretty much a mature, fully developed La Nina. The question is, how strong and how long will it last? So here is the forecast from April. I don't know whether we've shown this before or not, but you can see this is every model, dynamic, statistical, that's used for monitoring El Nino. They all have a big spread, but the blue is the consolidated forecast, if you will, and it says not moving to La Nina. Yeah, down to minus half a degree for a month or two, and then rising mysteriously. But the CFS model, and let's see if we can find it. It's the green. Oh, there it is, right there. It has us going into La Nina. The purple, and I'm not sure which model that is, and this darker purple, both are even farther into La Nina than the CFS model. So there's these three outliers here that say La Nina, where everything else says neutral or maybe even tending towards El Nino. We know that is in fact not the case. So short term, we're not in bad shape. I mean, series of storms, forecast for the southern hemi. Swell is in the water right now. Another one behind. It's basically swell all week for California. Another storm forming behind that, and yet maybe a second storm behind that. So a good run of southern hemi swell. The interesting part is easterly anomalies in control of the Kelvin wave generation area. So the MJO is literally having no effect on the storm track, which is a good thing. We'll get some surf. But it sort of does not bode well for this winter in that the MJO machine has a lot stronger effect in the northern hemisphere in the winter, and we expect we're moving into a period of no active phases of the MJO, or at least active phases that don't have any, westerly anomalies, no Kelvin wave production, no imparting energy to the jet stream. So it looks like we're going to be at the mercy of La Nina this winter, but we can hope that the CFS model and some of the other models are not right. But we'll see. We're just out of the spring unpredictability barrier now, and I'm sure that all the other models will figure out and sort of sense where we're going to be over the next month. But right now, the CFS model is doing a great job and pretty much on track and definitely pointing towards a La Nina pattern for this fall. All right, so if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, subscribe, hit the button there. You'll get email notification. If you don't want to do any of that stuff, that's okay too. Go to stormsurf.com. That's our website. Just about all the data you've seen is available there. You can track along daily, or come next week and we'll do it again. We do this update pretty much Sundays every week, and we plan to do it again next week. And that's it for tonight. So thanks for watching. We'll see you again next week. Same time, same channel.